Hello everyone, welcome back to LeetCode Daily Live where I do the daily question uncut. So we have a medium today. It's called count the number of good subarrays. So let's see what we are given first. So we have nums, which is 100k long, and all of them are just integers, positive integers. And we are also given a positive integer k. So let's see what the question wants. So we want to return the number of good subarrays. So I think subarray means it is contiguous, and it has to be non-empty as well. So what is a good subarray? It is good if there are at least k pairs of indices such that I is more than j. So like ordered pair of indices, and I is equal to j. Right. Yeah. So like again, because it is 100k, we need a quick way of doing it. But what we can do is like what we can do is that like let's say we have like three elements in our subarray that are the same, right? Well, we can generate like three pairs, right? So oops. So if you have like 1 1 2 1, you can make like 1 1 here, you can make 1 1 there, and 1 1 there. And if you have like another one, um well, yeah, so this is like the arithmetic series, right? So like for the first two ones, well, you have one way. If you have another one, well, this one can form a pair with each of the previous ones. This one can form with all the previous ones. So that's why like we can use an arithmetic series to calculate quickly how many um I guess like pairs we have. Um yeah, so yeah, the other thing to notice is that um if your subarray does not have enough pairs, none of your none of like none of the subarrays of your subarray are going to have enough pairs. So I guess this is like a bit like trivial to mention, but like it will help you think about that like if you start at the front, and let's say like you see the whole array and you still can't find like a subarray with enough pairs, well, that means none of the subarrays will work, right? So we can definitely like just start at the front. So we get up to the point where we have at least k pairs, and then I think what we can do is we can see how far we can move. Like from the how far we can move on the left side until we don't have a subarray with at least k pairs left, and then we will like expand again. So I think that would be like either like on or n log n. Yeah. So if you look at if you look at this example, k has to be 10. So yeah, so you need all of them. For this one, k is 2, so that means you just need two pairs. So yeah, so like for example, we will like keep looking. So we found one pair here, we found two pairs here, and so we can like start to like shorten the amount. So like we look at this, but this doesn't work anymore, so we'll like keep looking and stuff. Yeah, and because we are only moving we are only moving the bounds on like we're only moving the two bounds linearly. That will be on as well. So yeah, I think that should work. Are we? Yeah, are we sure we have counted everything though? Let me think. I I think so, because like when you reach a subarray that doesn't have k pairs, that means like you will have counted all the ones that has already. Wait, is that true though? Yeah, I guess like Yeah, I am missing something. So this subarray has two pairs, right? But that means if we extend it further, we are going to get at least two pairs as well. So that means like wherever our right bound is, we have to like add the number of ways like we can expand on the right as well. Yeah, so I think like if we do that, we would be able to count every um subarray. So yeah, let's get coding. So what we need, I think we need a counter. So a frequency map. We can use default date here. Yeah, so from collections, import default date. So, well, we want to keep track of like number of pairs. So we start at 0, and then we want to keep count of number of subarrays as well. I spelled that wrong. Okay, there we go. But like that means when we first add a number, and if that number hasn't been seen before, well, like if we look back at our arithmetic series, we actually like have a 0 here, right? So like when we first add 1 here, we don't add any more new pairs. So our number of new pairs depends on how many, like what is the frequency of that number from before, right? So we can also calculate that very quickly. Yeah, so actually, if you ignore like dictionary being like not O1 sometimes, our average time complexity should be it should be ON. So that's very good. And yeah, I guess I'll I'll just start coding now. So we have a left bound and a right bound. We want to start at 0, 0 first. So I think what we should do is while the right bound, yeah, I think the right bound should be exclusive. Yeah, so while right is smaller than length of nums, we can add the current element in. So the current element would be nums r. So we want the frequency of nums r. We want to add 1 to it. But actually before that, for number of pairs, we want to calculate. We want to add the number of pairs we can form by adding this number here, right? So how do we do that? We can just get the previous frequency of nums r, and then we increment it afterwards. So now yeah, I think we should also increment r as well. So if number of pairs is at least k, then that means we have found a subarray that works, right? So we can so for number of subarrays, we can add, well, actually, if our right bound is, because it is exclusive, so like if right bound is 1 and left is 0, that means like we've only included like from 0 all the way to like right before r, right? So it will be here. So that means we have another like length nums minus r ways of forming like valid subarrays. So we can just do that. Yeah, and I think like what we can do is we need to move left bound up. So we want to move the left bound until we don't have a subarray anymore. so we can like keep counting the rest. So maybe we put it up here. So wait, I have a better idea. So we can just do something like while num pairs is greater or equal to k. So we do this, and then we want to move the left bound up once. But by doing this, we are taking away whatever left bound number is. So like for example, like we have this thing, right, which is like a good subarray. But when we move the left bound, we are removing like the first element. So we have to look at the frequency and like deduct the number of pairs accordingly. So we can just do nums L. So if we have like, if we originally have like 2 3s, that means we're getting like rid of one pair, right? So for the number of pairs, we have to decrease by that, and then frequency of nums L, we can decrease that by 1 as well, because like we've removed one. And if that still works, we'll basically like just go back here, and then like we'll keep adding, because like moving the left bound up does not really affect how many like more arrays you can form on the right hand side, right? So yeah, I think if we do this, and yeah, the last thing we have to worry about is, yeah, so like what happens if R is, maybe we don't need yeah, because like when R is equal to length of nums, this is going to raise an error, and we don't want that. But yeah, I think like when we get here, so when it got incremented to length of nums, we would have reached the end already. So we can just do that, and then like it'll run the loop and like get the rest. So I think that should work. Oh, oops, what did I do wrong? Yeah, maybe we can print out the we can print out number of pairs, and then we can print out number of subarrays. Wait, actually in this case we didn't get any. So for the final one, that's quite strange then. Oh, am I miscalculating here? Oh yeah, I think I forgot to so like if R is 1, yes, we have like 4 more elements to add here, right? So like if R is 1, the length is 5. But then we also have to include like when we are not actually adding any elements. So yeah, that's why like we should have a +1 there. And I think yeah, it should work now. Nice. Yeah, I'm sorry, I feel like I didn't explain this quite well, but like basically like you just need to do the fast way to like calculate, like because the other, like the brute force way is like you go through each of the subarray. So well, you have n squared amount of subarrays, right? So like the first one could go with like any of these. The second could go with like any of these. So you have like n squared amounts. But what I've done is like I've found like a good subarray, like the smallest good subarray that starts with our like current, like that starts with the left bound. And if this subarray is good, well, if you add more elements to it, it will still be good, right? So like basically I do that to find the number of subarrays quickly. Yeah, I'm not sure if I've explained that quite well, but yeah, that's basically how how you like go with most of these questions, like especially like when you look at the 100K length, like you know that you need some quick ways of doing it. But yeah, thank you for watching, and I'll see you tomorrow. Bye.